Voila. Okay, a very brief sales pitch. Inventa Partners are a consultancy firm. We specialise, as Michael said, in looking at the commercial models for utility and district energy networks, working for a combination of local authorities and private developers. Our work is focused on identifying on each project what the challenges that are being faced are, our process of analysis, procurements, that might be procuring expertise, capital, and joint venture partners, and negotiation, all leading to, in the end, investment. For a private sector client, the developer, that might mean a couple of million off their bottom line as an investment towards the district energy infrastructure they're having to put in. For a local authority, it's the same. It might, however, result in that instance in lower fuel energy prices, something like that. We work for quite a lot of different organisations. We're a small consultancy, but we get around. Tonight's topic, sharing heat networks, is one that's close to our heart, as we work for. We set up heat networks, but we also negotiate against them in lots of instances around the UK where there are incumbent heat networks. So it's something we kind of spend a lot of our time doing. There are lots of different sorts of heat networks, but what I've tried to do there is break them down into three different types. There's a heat network that goes in a city centre to serve existing buildings. Birmingham, Southampton, places like that would be a good example. They're usually, entirely owned by an energy company who manage both the creation of the heat and the distribution of the heat. They're usually financed by that energy company, although, as I'll show you in a minute, not entirely. And any sort of expansion of that network or looking at other heat sources is entirely driven by that energy company. ESCO stands for Energy Services Company, by the way. Another sort would be something that's entirely development based. So a developer out there somewhere, 700 homes, planning says they have to have a heat network, so they build a heat network. It's built to it's sized for that development, and that's pretty much how it'll stay. It's owned by the developer, usually leased to an energy company, financed by both in the sense that there is a value to that asset, and if the developer's working with us, we get them a chunk of capital towards the cost. And there's another sort, which we're seeing more and more of, which is a network driven off the back of some form of waste heat. The biggest and the most useful there is something like an energy recovery facility that has to get rid of its heat if they're in the right locations, but it can be any sort of waste heat source, data centres, anything that is big enough to warrant a heat network. They're all different, but the issues for them all are pretty much the same. Just quickly, and I apologise if some of this is going to be a bit sort of teaching your grandmother to suck eggs, but it's very important to understand how district energy networks work financially in order to understand whether they can or can't connect together. If you take a hypothetical network, it might have any of those guys investing in it. It might have just one, it might have all of them. What they're investing in is an asset, and that asset is usually plant, so how the heat's created, and then distribution, how it's passed around the site or the area. And that is the asset of of a district energy network. How the money's made, again, this is high level, but for a developer, for example, they'll be looking for some capital from an energy company who's going to operate it, assuming the developer isn't going to operate it themselves. They'll be looking for some form of income, perhaps. That could be called rent. It might be a share of profits. It might be nothing if the capital is high enough, and that's their interest. They're also looking to realise their land value, and as the district energy network is a compulsion of planning, they're not going to realise that value without putting it in, so they don't really have a choice. Whoops, wrong way. For an energy company, it's about the acquisition of assets. They want to own stuff that's in the ground. They don't really want to own energy centres, half of them, but well, the other half do. But what they're really interested in is the customer, and the only way you get to the customer is through the distribution. So they're interested in revenue, and they're interested in growth, really their own growth rather than the growth of the network. And you'll see a lot of networks. Some have been very successful in expanding, but some haven't. On the public sector side, depends on what they're doing. You haven't got many public sector dominated or owned projects nowadays because there isn't that much capital around. But they can be involved in other ways. They're interested in assets if they've got the capital to acquire them, to own them. They're interested in revenue if they can find value adds to bring to a project that mean they can get something back. And importantly, they're interested in planning, seeing the implementation of their planning policies through the delivery of networks. Any other investors are interested in all the above, and obviously the bottom right there, the environment, we're in a lucky position where other people have to think about that when they design and when they plan. We're about what's the value of it once it's planned, and what are the environmental benefits are kind of left to other people. Unfortunately for a district energy network, the revenues you get off them are never enough to pay for them, or rarely, not on their own. For an ESCO on a new development, for example, so let's say this is 1,000 homes being built in East London. The developer will usually pay for it all, and then the energy company will pay them what they consider to be the value of that asset, and that probably won't be much more than about 30% of the cost of putting it in. So if you're going to spend 4 million on a district energy network, you won't get 4 million back. The reason for that, though, is pretty much that it is justifiable in some ways. Some of it is just the cost of complying with planning from a developer's point of view. In the same token, they're getting their land value back. They have to put it in, so they recover that. And there's some money they're not spending. They haven't got to put boilers in. They haven't got to put a gas network in. There are other avoided costs that will balance it out a bit. But it's still an increased burden on a development. A new network going into a town centre that's going to connect to a town hall, a leisure centre, hospital, whatever. Again, it can't pay for itself. The way it's paid for is the energy company who's coming in, say Birmingham would be an example, they'll put in the network, but the only way they'll make money off it beyond revenues is to charge a connection fee to the buildings that connect to it. And that connection fee is usually based on avoided cost. So they might say to an IKEA, right, you haven't got to put plant room in, you haven't got to put boilers in, all of this, so you're avoiding spending £1 million, so give us 750,000 and we'll connect you. And that's how it's funded. Within those connection fees, the majority are commercial connections, or the majority of the capital will come from commercial connections, but obviously there's a lot of public sector buildings connected. They are usually worth, perversely, a little bit less to a network because they're usually more tariff sensitive. Therefore, the revenues are even lower from those customers. Simplistically, heat network is no different to any other business. You've got standing and variable charges on the heat you sell to customers, both residential and commercial. If you've got CHP, you're generating electricity, and you're probably selling that to the grid rather than over private wire, and you're getting revenue off that. You might be getting incentives depending on what fuels you're burning, so renewable heat incentive might be applicable. On the costs, you've got, biggest cost is always your input fuels. If you're burning gas, biomass, whatever, that's always the big one. And you've got the usual other costs in there, all leading down to a profit line at the bottom, and that would determine what the asset value of that network is. Pretty much without exception, networks throughout the UK are owned, networks and generation and distribution, is owned by the same person. So if Scottish and Southern Energy own a network, they probably own the generation that is at the end of it and own the customer relationship at the other end. That keeps life simple. Contractually it's easier, and it means they can bring more funding to it because they own the whole lot. However, that doesn't help with heat sharing. There's all sorts of ways to share heat, but broadly it means someone selling heat to someone else. There's got to be a commercial transaction in there somewhere. Not many people will give something away. In this example, we've got a network, a heat network, an existing heat network, and either a development or a customer at the other end. When you make heat, you can make heat off gas for about 3.2 pence a kilowatt hour. You can't sell it for too much more than that at the other end. Once you build in you do sell it for a lot more than that, but once you take out all your costs, there's a limit to how much you can charge for heat before the property at the other end either won't buy it, or if it's a development, they become unsaleable. So the margins are quite small. The gap between those two things, making it and selling it, is narrow, which means when you've got to build that, and if that's in an urban area, that could cost you between £1,000 and £2,000 per metre to put those pipes in. It's quite hard to justify if you're creating heat here at a price of 3.2 pence. So just to give you some scenarios, the network here, if that's a single building on the right, it's actually quite easy. If that's, say, an IKEA store, and these guys want to sell to them, they can say to them, it's going to cost me £500,000 to get the pipe to you, but you're going to save all of this. Give me a connection fee, and job done. And that's not complicated. But if that's a development, a couple of thousand homes or something, it's much more complicated. In one scenario, these guys want to sell heat. They'll fund the infrastructure. They'll charge a connection fee. Those guys will avoid costs, and they'll be willing to pay. And it works quite well. And it's working in several cities in the UK. However, if that's a development, and the reality of the UK at the moment is the majority of heat networks are being born out of developments due to the planning compulsion, that developer has a choice. They can either say, yeah, okay, I'll buy your heat, great, and I'll pay a connection fee, but hang on a minute, I've got to put in all of those red lines to pipe the heat around my site, so I've got to distribute it myself. So I'm not building an energy centre. I haven't got to buy plant unless I've got to provide my own backup, but I have got to pay for an awful lot of infrastructure to go onto my site. But, might work. Option B is they do build an energy centre. They don't create that black line in the middle. They fund their own on-site infrastructure in the same way they would have to, and then they go out to market and they find someone to pay for some of it. So their £4 million cost went down to 3 million, but they had to pay £500,000 connection fee. So they're £3.5 million, they saved £500,000. On the other side, they've got to build an energy centre, but of the £4 million cost, we can probably get 1.5 to 2 million as an investment. So you end up not gaining much by connecting to network A, which obviously stops networks expanding and stops urban heat sharing. That's the problem we're seeing in Birmingham, in Southampton, everywhere we go where there's an incumbent heat network, we find ourselves negotiating against them and having to get rid of this. And when you start getting rid of that, it becomes very difficult to fund. So how do you go forward? And I'm conscious I'm racing along here, but what works well, what always works is if there is a very large connectable load with a single customer. I'll use the IKEA example again. What works better is if you can buy your heat cheap, if you can find a source of cheap heat, because you can widen the margins and you can invest in infrastructure. It works well if someone's developed something and they've got a big engine and they want to generate more and more electricity and make more money, but they can only do that whilst complying with their environmental restrictions by dumping the heat somewhere, and they can't dump it into the atmosphere. Therefore, they want someone to buy it. There's a negotiable deal in there. And the last one, I'll come back to this one in a minute. The last one is if, for some reason, we're forced to separate generation and distribution. And we've looked at lots of models in this. The only real, for those who don't know, that would kind of replicate the electricity environment at the moment. And again, this is high level and simplistic, but electricity is divided into distribution networks throughout the UK. Those guys don't supply the electricity. The supply runs across, so someone living here buys their electricity from somebody, it goes across the pipes, and the supplier pays a use of system charge to the owner of the wires, and that's how they make their money. You could do the same with heat. You could have someone else own the pipes, and they charge a use of system charge. Trouble is, heat pipes are a lot more expensive to put in by orders of magnitude. Therefore, this use of system charge would have to be a lot higher to cover the costs. Therefore, no one's going to do it unless you widen the margin between between the manufacturer and the sale price. There's only two ways to do that. One is to charge more for heat, which is effectively charging the proper price for energy, which would be unacceptable to everybody. The other is to get waste heat, to find cheap heat. So as far as we're concerned, as long as developers are compelled to put heat networks in, that'll carry on, and there'll still be heat networks. They'll be built small, and they'll be built self-contained, and they'll never expand because they won't have enough capacity to serve anybody else. Incumbent networks dotted around the UK can expand and will expand, but they're only going to really expand to, as long as people like us exist who will be saying to developments, you could connect to them, but we can get you a better deal. You're going to get 2 sets of pipes running down your road, but hey, it'll save you £1 million. So it's going to be hard to connect to developments. So in our view, the only way this is really going to happen is to look at this, and it ties a little bit in with what Andy was saying. If you can find waste heat, an example would be in Sutton, that Michael mentioned. Sutton have a landfill site adjacent to a large development and a lot of property going out to the east of that development. The landfill is burning methane constantly, 4 megawatt constant output of heat into the atmosphere. And the plans in Sutton are to capture that heat, bring it across the landfill site and straight into the development. Just to the north, the same operator has just put in a planning application for an energy recovery facility, which will take that heat availability up to about 115,000 megawatts in a year, megawatt hours in a year, which will be enough to serve half the borough, if we were able to get the model right to get the pipe out there. The beauty of that is the heat will be cheap. The heat will be based on factors that aren't energy related because there isn't an input fuel that we need to think about. There are others. Sheffield is feeding a large chunk of the city off an energy from waste plant. And it significantly increases the opportunity to have these things in relative urban locations. Same with the data center example. You put these things in the right place and you can begin to look at growing networks. If you do that, you can begin to look at separating distribution and generation, and then heat sharing becomes viable. Otherwise, I don't think it's that viable unless you can do that. Done. Thank you.